let's examine problem 12.5a, a constrained resource problem. So in this problem, we have a wonderful dilemma. And the dilemma is we have too many customers. We can't supply them all. How should we deal with the problem of having too much demand, not enough supply? There's some constrained resource that's saying we can't produce all that we want to produce. So let's read the problem and we'll talk about this dilemma. Again, a nice dilemma to have. We can see it in real companies as well, where they absolutely are not able to meet demand. What should they do? So here's the problem. Wondrous Aromas Company has 3 lines of perfume: red, green, and blue. After mega celebrity Caitlin Spencer tweeted that this was her favorite line of perfume, demand for all 3 products has been off the charts. The company has a problem. It has a limited supply of orchid nectar, a common ingredient in all 3 products. Orchid nectar costs $5 per gram and is the major selling feature of all 3 perfumes. Cost data follow. So here we are. You can see the red makes us $100 a unit, green 70, and blue 25. And it says, which product would you recommend the company focus on producing first, second, or third? So in a world where all else is equal, we wished every one of our customers was buying red. Why? Because it sells for $100. I mean, it profits us $100. The contribution from each sale is $100 per unit. It's the most. So if I could sell 100 units of red, 100 units of green, 100 units of blue, I'd take red all day, every day. Right? Red makes me the most money per unit. That's the one I'd like to sell. Of course, companies don't always work that way because they have different product lines to get different markets, different people interested in their product that can afford different things. So we've got a problem, though. We don't have enough orchid nectar to make all the things we want to make. So orchid nectar, of course, is a direct material, and you can see there's $50 worth of orchid nectar in the red, 30 in the green, and 20 in the blue, and that's probably why they are cheaper as we go down the line. There's other direct materials in each one, and labor and variable overhead as well. So our challenge is, if we have a limited or constrained resource, which we do here, we have a limited amount of orchid nectar, we don't want to make the most profit per unit. That's generally a good goal, right? A highest contribution margin per unit would be something desirable, or even the highest contribution margin ratio, CM ratio, which is 100 divided by 200, CM divided by sales. 100 divided by 200 is 50%, 0.5. 70 divided by 160, can't do that in my head, 43.75. And 25 divided by 80 is 31.25%. So you might think, okay, well, highest CM ratio means the highest percentage markup. We'd like to sell red the most as well. And that would be, again, normally we would like to sell them in that order: red first, then green, then blue. However, we're short on orchid nectar. We're high on demand for all of the product lines. So here's what we want to do. We want to sell the product line, not that makes us the most money per unit. We want to sell the product line that makes the best use of our constrained resource. This is what constrained resource decisions are all about: making the optimal use of your constrained resource. How do we do that? Pretty easy. We don't look at CM per unit or CM ratio. No. We look at CM per unit of constrained resource. Sorry about my writing. Unit of constrained resource. Oh my God. I got to erase that and try again. Unit of constrained resource. Okay. So what is our constrained resource? It's orchid nectar. What is the unit? Well, it's the gram. So we want to know the CM per gram of orchid nectar. So here's what we know. We know our CM for each of these. It's Red is 100, green 70, blue 25. 170, 70, not 75, and 25, and that's RGB, red, green, blue. But what we need to figure out is the number of grams of orchid nectar. I'll just call it ON, orchid nectar, that goes in each bottle. So we know that the orchid nectar cost going into red is $50, and we know orchid nectar costs $5 per gram. So working there, you can go, okay, $50 worth of orchid nectar cost me $5 a gram. There must be 10 grams of orchid nectar. 50 divided by 5. There must be 10 grams of orchid nectar. For the green, $30 worth of orchid nectar, there must be 6 grams. For blue, $20 worth of orchid nectar, there must be 20 divided by 5 is 4 grams. So let's figure out our cost per gram, our CM, not our cost, but our contribution margin per gram of orchid nectar. So here it's 100 divided by 10 is $10 per gram. Every gram of orchid nectar I put into red spits out $10 towards my bottom line. For green, 70 divided by 6, 1167. So for every gram of orchid nectar I put in, I get 1167 of profit spitting out. And 25 divided by 4, 625 per gram of blue. So which one uses my constrained resource the best? Green, absolutely the best. We just divide by the number of units of whatever our constrained resource is. For a busy person, it would be hours, or it could be pounds or kilograms of a material. In this case, it's just grams of orchid nectar. So my first choice would be green. My second choice would be red. My third choice would be blue. We can figure this out if you say, look, we have 100 grams of orchid nectar. Okay, 100 grams. What should we make? If we made all red, we would be able to produce, with 100 grams, we would be able to produce 10 bottles, right? 100 grams is 10 bottles. 10 bottles times the contribution margin would give us $1,000. If we only made green it takes 6 grams. So we could make 16 bottles, almost 17 bottles, but let's just say 16 and round down. 16 bottles times $70 is $1,120. With blue, we could make 25 bottles. 25 bottles, because blue takes 4 grams times $25, is $625. So again, if we only had 100 grams and we just focused on one of them, of course we'd focus on green. So green is the one we should be focusing on because we do have a constrained resource. Okay. Moving on to part B. A supplier emerges willing to provide the company with more orchid nectar, but for a major premium. What is the maximum the company would be willing to pay per gram of orchid nectar as long as there was unfulfilled demand for all 3 perfumes? Okay, so first of all, assuming there's unfulfilled demand for green, that's the one we'd be willing to pay the most for because that's the most profitable to us. So ignore red and blue. We're just looking at our most profitable product. How much would we be willing to pay per gram? Well, we're making $11.67 per gram of green, and within that, we're already paying $5 per gram. So if we take materials out of the equation, we have room. That's our profit per gram, $11.67, but in there is $5 a gram. That's what we're already paying. So $16.67 per gram would be our break even. If they charge us $17 a gram, we'd start to lose money on this. If they charge us $16.50 per gram, we're making a little bit of money. $16.67 is the absolute maximum we would be willing to pay. Maybe just a couple pennies less to cover the rounding here, but $16.67. You might say, well, why would I ever pay that much per gram? And the answer is it's not good to have unfilled demand. What happens if these perfume choosers decide there's all this demand for yours. They go to the perfume shop, they don't find yours. They end up buying Chanel or some other, I don't know, brands of perfume. They end up buying another brand of perfume and they become loyal to it. Well, that's bad news. That's a missed opportunity. So in the short term, it might be wise just to say, look, we'll pay whatever you want. We'll even take a loss on this. But the most we'd be willing to pay and still break even is $16.67 for the green. For the red, it would be 10 plus 5, it would be 15. For the blue, it would be $11.25. So once I ran out of demand for green, I'd be paying $15 for a gram of red, and I'd be willing to pay $11.25, just adding 5 to both of those numbers for a gram of blue. All right, folks, that's it for this video. Part 2 was fairly complex. I hope it was well understood. Stay tuned for our next video.